This video is about solving literal equations. So when solving a literal equation, you need to isolate the requested variable. Just like solving for numbers, you need to do inverse operations in order to solve for a variable. So we're still using the same inverses, addition, the inverse is subtraction, multiplication, the inverse is division, in order to solve for the requested variable. So in this case, we have to make sure we're reading so we know what we want to solve for. So in number one, it says solve for A. So that means A should not move from the place it's at. So how would we get A by itself? Well, we have A plus B, so the inverse is to subtract B to both sides. So we have A equals C minus B. We don't know what C minus B is because we don't have values for these variables, so we're just going to leave it as an expression. Number two, solve for J. So J needs to stay in place. So we have J minus K, so the inverse is to add K to both sides. So we get J equals M plus K. Number three, C over D equals F, and we want to solve for C. So we don't want C to move. So in order to get C by itself, right now there's division, so the inverse would be to multiply by D. So C is equal to F times D, or we can just write it as FD because we know that means multiplication still. Number four, PQ equals R, solve for Q. So we don't want Q to move from where it's at. So what we need to do then is if there's multiplication, the inverse is to divide by P on both sides. So Q equals R over P. Number five, solve for C. So first thing we need to do, just like when we solve for a variable, is we need to see if there's anything to add or subtract over. So there's a minus D, which means we have to add D to both sides. BC equals G plus D. And then we can divide. So to get C by itself, we need to divide everything by B, which we can write as C equals G plus D over B. Since they're all variables, there's nothing that we can reduce, so we're going to leave the fractions. Number six, solve for W. So we want W to stay in place and everything else to move. So first thing we need to do is we want to subtract Y from both sides. We get W over X equals Z minus Y. And the next thing we want to do is multiply by X on both sides. Be careful when you multiply by X, this is a quantity that needs to stay together. So both things need to be multiplied by X. So we can write this one of two ways. We can just say X times Z minus Y, or we can distribute the X. So we get XZ minus XY. Number seven, we need to solve for X. Notice that this time there's also some numbers mixed in here when we're solving for the variable. So in order to solve for X, what we're going to do first is we're going to add 5 to both sides. So we get AX equals -3. Since it's a number that we can work with, we're going to simplify the numbers then. Then to solve for X, we're going to divide both sides by A. And we're going to leave it as a fraction because we don't know what 3 divided by A is, because we don't know the value of A. Number 8, solve for M. So we want M to stay in place. So to solve for M, our first step would be to subtract B from both sides. Y minus B equals MX. And then to get M by itself, we're going to divide both sides by X. So M is equal to Y minus B all over X. When we start graphing in a few units from now, a skill that we need to have is to be able to put an equation into slope-intercept form. So this means we need to solve and isolate for y to get the equation in the form of y equals mx plus b. So y should be by itself, and the x term and the constant needs to be on the other side. So in number 9, we need to isolate the y. So to get y isolated, right now it's a positive 5x. How do you move a positive over? You subtract it from both sides. Now, this is where we have to think about like terms. Are 12 and x like terms? No, because one has a variable, one does not. Think about our y equals mx plus b. So we're always going to put the x term in the front. So we would have y equals negative 5x and then plus 12 because 12 was positive. Number 10, we have y minus 3x equals negative 1. So we're going to add 3x to both sides. Again, negative 1 and 3x are not like terms. So we rewrite it as y equals 3x minus 1. Get in the habit of putting the x before the number because that's going to be our slope-intercept form that we're going to use when we start graphing in a few units. Number 11, to solve for y, there's two steps this time. So first, we need to move the x to the other side. So we're going to subtract 4x from both sides. 2y equals negative 4x minus 10. Now, when we divide, because there's a number in front of y, each term gets divided by that number. So we're going to divide everything by 2. Instead of writing just one bar, we're going to write them individually because we have to be able to reduce them. So y equals negative 4 divided by 2 is negative 2x. 10 divided by 2 is minus 5. Let's try one more example. So number 12, we're going to start by adding 5x to both sides. Negative 4y equals 5x plus 20. Then we're going to divide everything by negative 4 because that's the number in front of the y. So y equals, we can't reduce this first fraction, so we're going to leave it as negative 5/4 x. 20 divided by negative 4 is minus 5.